Imagine a night sky untouched by light pollution. Thousands of stars blaze, their patterns unchanging across generations. For the ancient Babylonians, this celestial tapestry wasn't merely beautiful. It was a clock, a calendar, and a divine message board. This civilization, nestled in the fertile crescent of Mesopotamia, made breathtaking strides in astronomy. They were pioneers in deciphering the movements of celestial objects. Join us as we journey back in time to uncover the secrets of Babylonian astronomy. The land of Mesopotamia, nestled between the Tigris and Euphrates rivers, was a cradle of civilization. Known for their advancements in mathematics, writing, and law, the Babylonians were intellectual giants of their time. Towering ziggurats, stepped pyramids dedicated to their deities, dominated the skyline. From these lofty platforms, priests meticulously charted the movements of the stars and planets. Their observations, recorded in cuneiform script on clay tablets, formed a detailed log of celestial events. They noticed that certain celestial events, like eclipses, didn't occur randomly. Clay tablets, more durable than paper, have survived for millennia to tell the tale of Babylonian intellect. These tablets, inscribed with cuneiform writing, are more than just historical artifacts. They are scientific documents. They reveal the Babylonians' methodical approach to studying the cosmos. This meticulous record-keeping allowed them to identify recurring patterns in celestial movements. One such pattern, the Saros cycle, was key to their eclipse predictions. The Babylonians, through careful observation and mathematical analysis, identified this cycle. Invaluable to future generations of stargazers. Ancient Mesopotamia, often dubbed the cradle of civilization, was a fertile crescent of land nestled between the Tigris and Euphrates rivers. The Babylonians, inheriting knowledge and traditions from their predecessors, emerged as a dominant force in Mesopotamia. Their empire, centered around the majestic city of Babylon, exerted considerable political and cultural influence throughout the region. Within Babylon's walls, a vibrant intellectual culture thrived. Scribes, trained in the complex cuneiform writing system, meticulously copied and preserved ancient texts. The Babylonians' emphasis on education and the preservation of knowledge created a fertile environment for scientific inquiry and discovery. The Euphrates River, a lifeblood of ancient Mesopotamia, played a pivotal role in the rise and prosperity of the Babylonian civilization. Its annual floods, while sometimes destructive, deposited fertile silt along its banks, making the land ideal for agriculture. This abundance of food allowed the Babylonians to focus on pursuits beyond mere survival. They developed sophisticated irrigation systems, further enhancing their agricultural output and ensuring a stable food supply. The Euphrates River also served as a vital trade route, connecting Babylon to distant lands. This constant exchange of goods and ideas exposed the Babylonians to diverse cultures and intellectual traditions, enriching their own and fostering a spirit of innovation. For the Babylonians, the sky wasn't a distant, unknowable expanse. They observed that the sun, in its daily journey across the sky, marked the passage of time. They also recognized the cyclical nature of the seasons, linked to the sun's changing position in the sky throughout the year. The Babylonians, heavily reliant on agriculture, developed a keen understanding of these seasonal shifts. The moon, with its ever-changing phases, provided another unit of timekeeping. They recognized that the moon's phases weren't arbitrary. They were a predictable consequence of its movement relative to the sun and earth. The moon, a constant presence in the night sky, held a particular fascination for the Babylonians. They meticulously observed its movements, charting its path across the celestial sphere with meticulous care. They observed that the moon didn't simply disappear during its new phase. It was still present, but its illuminated side faced away from Earth. This realization marked a profound step in their understanding of the cosmos. They began to see the celestial bodies not as capricious deities, but as objects governed by natural laws. This understanding of the moon's movements was key to their ability to predict eclipses. The Babylonians possessed an exceptional ability to identify patterns, a skill honed through their meticulous observations of the natural world. They noticed that eclipses, while seemingly random events, followed a predictable cycle. This cycle, which they dubbed the Saros cycle, spans approximately 18 years, 11 days, and 8 hours. The Babylonians, through careful record-keeping and mathematical analysis, were able to identify this pattern. The Saros cycle's discovery had profound implications for Babylonian astronomy. It provided them with a powerful predictive tool, allowing them to anticipate future eclipses with remarkable accuracy. Imagine holding a piece of history, a tangible link to a civilization that flourished millennia ago. That's what Babylonian clay tablets represent. More than just archaeological artifacts, they are time capsules of knowledge, preserving the intellectual achievements of a remarkable culture. The tablets served as the canvas for the cuneiform writing system, a script named for its wedge-shaped marks impressed onto wet clay. Skilled scribes, trained from a young age, meticulously etched characters representing syllables, words, and concepts. They documented everything from mundane transactions and legal codes to epic myths and astronomical observations. Among the vast collection of Babylonian clay tablets, the Enuma Anu Enlil stands out for its astronomical significance. Named after the deities of sky and wind, this extensive work, compiled over centuries, represents a pinnacle of Babylonian astronomical knowledge. It served as a celestial codex, a comprehensive guide to understanding the movements of the heavens and their influence on earthly affairs. The Enuma Anu Enlil is a testament to the Babylonians' systematic approach to studying the cosmos. It meticulously catalogues celestial phenomena, including the movements of the sun, moon, and planets, as well as eclipses, comets, and meteor showers. For the Babylonians, the heavens weren't merely a backdrop to earthly life. They were an active force, influencing the fate of individuals and kingdoms alike. The Babylonians, lacking the telescopes and sophisticated mathematical tools of modern astronomy, relied on their keen observational skills and innovative methods to decipher the secrets of the heavens. One such method, known as zigzag functions, highlights their ingenuity in approximating complex mathematical relationships. These functions, represented graphically as a series of diagonal lines, allowed them to model the irregular movements of celestial bodies. The moon, with its ever-changing speed along its elliptical orbit, presented a particular challenge for Babylonian astronomers. To account for these variations, they developed zigzag functions, which approximated the moon's changing speed with surprising accuracy. These functions demonstrate the Babylonians' ability to innovate within the limitations of their time, developing effective methods for representing complex astronomical phenomena. For the Babylonians, eclipses weren't merely celestial curiosities, they were potent omens, messages from the gods carrying significant implications for earthly affairs. A solar eclipse, with its sudden darkening of the sun, was seen as a particularly ominous event, often interpreted as a sign of divine displeasure. Lunar eclipses, while less dramatic, also carried symbolic weight, their reddish hue associated with blood and potential turmoil. The Enuma Anu Enlil, alongside other astrological texts, meticulously documented these celestial omens, linking specific eclipse characteristics to earthly events. Kings and rulers, fearing the consequences of an ill-omened eclipse, often took drastic measures to appease the gods. The fear of eclipses fueled by these astrological interpretations highlights the power of celestial events to shape human behavior and decision-making. The Babylonian Empire, like all empires, eventually crumbled, its majestic cities falling into ruin. However, the knowledge painstakingly accumulated by Babylonian astronomers didn't disappear into the sands of time. Their meticulous observations, mathematical innovations, and predictive methods spread throughout the ancient world, influencing the development of astronomy in other cultures. The Greeks, renowned for their intellectual curiosity and contributions to philosophy and science, were deeply influenced by Babylonian astronomy. Scholars like Thales of Miletus and Pythagoras, credited with laying the foundations of Greek astronomy, likely had access to Babylonian astronomical texts and observations. The Greeks adopted and adapted Babylonian knowledge, incorporating it into their own developing cosmological models. The legacy of Babylonian astronomy extends far beyond the ancient world, its echoes resonating through the centuries to influence the scientific revolution. During the Renaissance, European scholars rediscovering classical Greek texts also stumbled upon references to Babylonian astronomical knowledge. This rediscovery sparked a renewed interest in ancient astronomical traditions and their potential contributions to understanding the cosmos. Nicholas Copernicus, the Polish astronomer who revolutionized our understanding of the solar system, was familiar with Babylonian astronomical observations. While Copernicus ultimately broke away from the geocentric model espoused by Ptolemy and other ancient astronomers, his work built upon centuries of astronomical observations, including those made by the Babylonians. Johannes Kepler, a key figure in the scientific revolution known for his laws of planetary motion, also drew inspiration from Babylonian astronomical data. Kepler, seeking to explain the precise movements of the planets, studied Babylonian observations of Mars, painstakingly recorded over centuries. These observations, combined with Kepler's own calculations, led him to formulate his groundbreaking laws, which accurately described the elliptical orbits of the planets. In a testament to the enduring legacy of Babylonian astronomy, their meticulous observations continue to be relevant in the digital age. Modern astronomers, equipped with sophisticated telescopes and computer models, still refer to Babylonian star catalogs, recognizing their historical and scientific value. These ancient observations, spanning centuries, provide a unique dataset for studying long-term celestial phenomena. For instance, Babylonian records of lunar and solar eclipses, meticulously documented over generations, have proven invaluable to modern astronomers studying the Earth's rotation. These records allow scientists to calculate the rate at which the Earth's rotation is gradually slowing down due to tidal forces. The accuracy of these ancient observations is remarkable, showcasing the Babylonians' observational prowess. Babylonian star charts, once etched onto clay tablets, are now being digitized and analyzed using sophisticated software. These digital reconstructions allow astronomers to compare ancient observations with modern star catalogs, identifying patterns and anomalies that might provide insights into stellar evolution, the structure of the Milky Way, and other astronomical mysteries. The Babylonians' dedication to recording the cosmos, preserved through the millennia, continues to inspire and inform modern scientific endeavors. The Babylonians, gazing upon the same stars that grace our skies today, saw more than just points of light. They saw patterns, cycles, and a celestial order that both captivated and motivated them. Their meticulous observations, recorded on clay tablets that have survived millennia, laid the groundwork for a scientific understanding of the cosmos. Their legacy extends far beyond their ancient Mesopotamian homeland. The Babylonians' ability to predict eclipses, a feat that astounds us even today, speaks volumes about their intellectual prowess. They didn't possess telescopes or sophisticated mathematical tools. They relied on keen observation, innovative thinking, and a deep reverence for the celestial clockwork. Their discoveries, passed down through generations and across cultures, influenced Greek astronomy, resonated through the scientific revolution, and continue to inform modern astronomical research. The Babylonian story is a testament to the power of human curiosity and our innate desire to understand the universe we inhabit. They remind us that science is not a modern invention, but an ancient pursuit driven by the same thirst for knowledge that compels us today. As we peer deeper into the cosmos with each passing year, we stand on the shoulders of these ancient stargazers, their celestial legacy forever intertwined with our own exploration of the universe.